Hello. This is going to be a walkthrough of the problem set, first couple of problems for Unit 10, or sorry, not Unit 10, for forces, talking about Newton's first and second laws. We used to call this Unit 10 back in a different numbering system, so that's why you'll see that there. Our key equations that we're working with today are weight equals mass times gravity, where W is weight, M is mass, and G is our value of gravity here on Earth, as well as the equation F net equals mass times acceleration. Let's go ahead and get started with the first three problems. Again, if you'd like to do option B, the backside, you can get started on the backside without me, but we're going to walk through the first two or three problems on the front side, option A. First problem, a dog has a weight of 257 newtons and is standing still. Calculate the dog's mass. I've already underlined some of our given information here just to help out. Go ahead and pull out the given information. Remember to list the variable, value, and units. Variable being the letter we use to represent the thing, value being the number, and then units being what we're measuring it in. And then go ahead and also include the unknown, please. Take a moment, pause this video, and see if you can do that with your seat partner now. All right, welcome back. Hopefully you were able to pull out the weight of 257 newtons, and you also identified the mass as our unknown. And then ideally you also listed our kind of unspoken piece of given information, which is that G equals 9.8, or here we've listed 9.81 because that's what IB uses. Remember that you can always just use 9.8. This example just used 9.81 this time. Go ahead and take a look at your equation sheet and see, is there an equation with W, G, and M in it? If there is, go ahead and write it right here next to the equation. And remember, you need to use the guess method in order to get full credit for this assignment. Cool. Hopefully you wrote down the equation W equals mg. Now go ahead and solve. So plug in your numbers and solve for m, please. If you know how to, you can isolate m first, but you don't have to. You can plug in the numbers first. Go ahead and pause the video, see if you can solve, and then when we come back, we'll go ahead and show you the answer. All right, welcome back. So hopefully you were able to plug in your numbers and solve. Here for this example, we went ahead and isolated m first. So I divided both sides by g to get mass equals weight over gravity. And then we plug in our numbers and we get 257 divided by 9.8 gives me 26.2 kilograms. The units are important for that. If you use 9.8 instead of 9.81, you should have gotten something very similar, probably about 26 or so. All right, now for the next part, part B says to draw a free body diagram for the dog. So start by drawing a box, and then I've given you a little hint that it says the dog is standing still. So go ahead and on your paper, draw a free body diagram for the dog given its weight of 257 newtons and that it's standing still. Go ahead and pause this video, and then when we come back, we'll show you the answer. All right, welcome back. So hopefully what you did is you drew in the weight vector going down. You showed me the variable, the value, and the units. And then you had the force of ground, or sometimes called the normal force, going up. Again, a value of 257 newtons. So that way we have these two forces canceling out. Cool, let's move on to problem number 2. Problem number 2 says a boulder with a mass of 523 kilograms is rolling down a hill and slowly gaining speed. It is accelerating at a rate of 0.320 meters per second squared. Calculate the net force on the rock. So start off by pulling out the given information and the unknown. Write those in here. See if you can do that without seeing the video first. So go ahead and pause the video. Welcome back. So hopefully you were able to pull out the given information of m equals 523 kilograms, a equals 0.320 meters per second squared, and that the net force is our unknown. So F net is our unknown. Go ahead and take a look at your equation sheet and see, is there any equation on there that has F net, a, and m in it. Cool. Hopefully you pulled out the equation F net equals mass times acceleration. Go ahead and plug in those numbers and solve, please. All right, welcome back. Hopefully you were able to solve. We have 523 times 0.320, gives me 167 newtons. And if we were going to go ahead and say the direction of it, we would just say downhill. Cool, those are the first two problems. Go ahead and see if you can solve the rest of the problem set now. Remember that the answers can be found at the bottom of the page, and if you scroll down even further on the digital version, you'll also see solutions with the free body diagrams, or not solutions, you'll see the free body diagrams drawn. If you need access to the full solutions, those will be posted on a separate link that will look something like this, where everything will be walked through. It'll be a Jamboard link where each slide will walk you through it. Remember that we're going to have a problem-solving assessment on this soon, so if you're just copying the solutions, that's not going to help you on the test. So make sure that you are actually practicing this and then just using the solutions if you get stuck or you want to check your work. That's it for me. Hope you have a good rest of your day, and we'll see you soon.